Good morning, this is Mr. McMurray. We're going to do some chemistry lab here. This is some steel wool, our first reaction that we're going to talk about. You notice on the paper up here, it talks about burning steel wool. All right, so we're going to do that first. Let me turn off the lights and we will come right back. All right, so first of all, we're going to get some fire here. Let me turn on. Maybe I didn't turn on enough. Let me try again here. There we go. All right, so now we have flame. I'm going to stick the steel wool in there and let's see what happens. All right, you usually think, oh, I can't burn metal, but as you can see, it sends off some nice little sparks there and everything. All right, so let's turn some lights on. All right. Turn that off. Here we go. All right. And I don't know if you can look at that close. You can't see a whole lot of changes perhaps, but there are some kind of more brittle. You might be able to see right there where I was holding on to it with the tongs. You can see it changed color a little bit. Okay. All right. So basically, first thing I want you to do is kind of describe what happened here. What did you see? All right. Then we want to go over here and we want to write out the formula. All right. We have iron, which is steel, is iron plus something else. We'll just say iron plus oxygen. Now, when we put it together, it combines and makes iron oxide. All right, very good. Iron oxide. So we need to write that down. That is our formula. Now, if you'll put the R's and the P's on it, like we did on the other worksheet, how many reactants do we have? Well, we have iron. It's going to be R. And we have oxygen, which is going to be a R. These are both reactants. Okay. And we have how many products? We have the iron oxide over here, which is going to be our product. Okay. So, there we go. All right. So we have two reactants that go together to make a product. So once you've written down what you saw happen, and then you're going to put your reactants in your product, and then the type of reaction, you're going to put it in a box down here. What it's done together is synthesis, okay? Because anytime we have two reactants, we put them together to make one chemical, then that is going to be synthesis. All right? All right, then. So that brings us to our next one, which is burning magnesium. Actually, we're going to skip that one, and we're going to go to the next one, which is copper and silver nitrate. We will come back to number 2 in a minute, but don't worry about it. But it's kind of like the other one, so we'll get a little break up a little bit. All right, so copper and silver nitrate. All right, so here we go. First thing we're going to do, we need to write out this formula over here since it's not written down this time. And copper is Cu. All right, plus silver, which is Ag. Nitrate tells you there's nitrogen, and 8 tells you there's oxygen. And just for the record, if you go up here and find the little subscript tool, you can put 3, NO3. Okay, then hit your subscript tool again. All right, and a dash and a arrow, and there we go. All right, so now the question is what's it going to turn into? Well, let's see. Well, first of all, let me show you the silver nitrate. I'm just going to make this bigger part so you can see it bigger. All right, this is a silver nitrate, very clear liquid. You can't see anything in it. All right, we're going to drop a piece of copper, which is about right there. Okay, shiny silver metal in there. And not much happens at first. Okay, that's at first though. Due to the magic of time-lapse photography, I have one that I did yesterday. All right, and we're going to show you this one. All right, if you look at it, the metal is no longer shiny and it has a fuzzy gray stuff growing all over it. I don't know how well you can see that, trying to get that there, but okay, it's not shiny anymore. like it used to be. Here's the shiny metal, but you can see how now it has all this stuff growing on it, like shaggy beard looking stuff on it. All right, guess what that is? That is silver, pure silver. Now, before you get all excited, it's not very much silver, okay? If we were to take all the silver on this, it's not going to be enough to be worth any money, unfortunately, but there you go, okay? So what has happened is the copper says, hey, I like the nitrate better than, or nitrate says, hey, I'd rather be with the copper, rather I'm more attracted to it than I am this silver. And so the silver has come out of solution all by itself now. That's why with a little fuzzy gray stuff on it. Plus, now we have copper nitrate. All right. And put that little thing there, so make it 3. Okay. And that's our new formula. All right. And so that would be our formula. And so basically the copper and silver had traded places. We'd had copper all by itself. Now we have the silver, the fuzzy stuff on there is the silver coming out all by itself. Okay. And now we have copper nitrate forming in the solution. All right. Now, next thing you need to do, label R's. We have a reactant, one element, plus a compound. So R and R. And over here we would have P and P. We have silver, an element. All right. So when we have an element, a compound, we have an element, a compound. All right. This would be what type of replacement? Single replacement. That is correct. And over here you need to type in what we saw happen or how it looked different. Okay. Now keep in mind this took a long time. It didn't just happen right away. All right. If we get this one that we just stuck in here, this is real time now. All right. You can already see, though, it's not shiny. It's getting kind of yucky, grayish looking. And it's starting to get a little fuzz, a little peach fuzz. Kind of like a guy just starting to shave for the first time, okay? All right, anyhow. So that's how we're starting off there, all right? So that would be that one. Now, let's go to our next one, which is barium chloride plus sodium sulfate. All right, our next thing is number 5, burning propane. And we've actually already done this example once. Here's the propane. All right, which is just the gas bottle. And I'm bringing this glass up here. I don't know if you can see it, but it's getting a little water vapor forming on the bottom, okay? Kind of like when you breathe on your glasses and it all fogs up. Okay, it's getting kind of a fog on it, okay? You may not be able to see that, so I know it's not real good. But if we hold that over it, you get a little bit of fog on it, just temporarily. Why? Because it's heating up water vapor, okay? And one of the things it gives off is steam, although you can't see it because it is so, steam is invisible, basically. So you can't see that, okay? So first of all, what do you see when we light it? Well, if you poof up, you got a blue flame. So obviously some heat going on there. It gives off a lot of heat and energy. That's why I couldn't put the glass right on the flame, because it would shatter the glass and break it or melt it. One of the two, which either one, neither good. All right, so if you write down what you saw, all right, then over here, we're going to write down the results of this, which basically, if it burns perfectly, would be carbon dioxide, which is CO2, okay, plus the water vapor which was coming off. So that is H2O, all right, or water. So that's what was coming off of that one. Okay, so we have propane plus oxygen in the air. And to have both those, it'll burn and give off carbon dioxide and water. Now, it probably also had carbon monoxide and some other things because it probably didn't burn perfectly, but there we go. All right, so if we look at this, we have hydrocarbon, some with hydrogen and carbon in it, plus oxygen. Okay, it could be, it is not synthesis because they don't end up as one thing. They have several products over here. So put your R's in your P's, but you got 2 reactants and 2 products. So it's not really a replacement because it's not like you have the O takes the H's part, makes CO2, but then the H and the O get together also and do this. So it's not quite really a single replacement either. So this is actually combustion. That's right. Anything we burn something, it's probably going to be combustion. All right. Okay. So let's go to our next one. Make sure you're typing that down, what happened, what kind of reaction it is, your R's and your P's up here. All right. You can pause it if you need to. All right. So here we go. Next one, magnesium and copper. Sulfate. All right, so we have copper sulfate. Copper is this bluish kind of liquid. Magnesium is a kind of silvery metal, but it's kind of tarnished, so it doesn't look very bright. Okay, usually kind of silvery, but it's reacted with oxygen in the air probably. All right, we're going to drop it in the blue liquid. Just in record, anytime you see a blue liquid or green, it's very likely copper of some sort. All right, we're going to drop it in there. Make it sink, maybe, maybe not. Doesn't see much happening there or not. All right, it's kind of making some bubbles around the copper. I mean, around the magnesium. See the bubbles coming off there. Yeah, they're starting to get a few more there, starting to build up. All right, bubbles coming off. And if you notice, whoops, it sank finally, okay. And you can see some little dark blue stuff floating around inside there now. That was not there before. All right.
What's that?
Okay.
All
right, so if we're going to do our formula here for that, we have magnesium, which was the metal, which is pure magnesium, plus copper, which is, right, Cu, and that is copper sulfate. So sulfate tells us there's sulfur, and that means there's oxygen attached. And in this case, it just happens to be a 4. Okay, all right, and then go back to regular prompt. Okay, now after it reacts, well, we have one reactant, okay, we have an element going in there. So probably the element's going to take the place into metal, so it's going to take the place of the other metal. So instead, we're going to end up with Mg SO4, and that would probably be the dark stuff that's starting to show up as solid and sinking to the bottom. Okay. Plus, well, I mean, sorry, actually, or copper coming out. So the copper is probably coming out by itself there, and that's the darker stuff. Sorry, the magnesium sulfate is probably still in solution. So I don't know if you can see that very good or not, but there is a lot of floaty stuff in there now. All right, as it's starting to react with it. Starting to get a few more bubbles. Bubbles are always a good sign because that means some kind of gas is probably beginning to thaw. All right. Okay. So there are probably some other products in this besides just those two, but we're going to keep it simple like that. Now, you need to put your R's and your P's. R's are everything on the left side. So there's 2 reactants, 2 products. All right. So we know it's not synthesis or decomposition because they either have 1 reactant or 1 product. So in this case, we are doing an element plus compound. So we know that magnesium just taking the copper's place, kicking it out. All right, and there we go. All right, so that would be a single replacement. All right, let's skip down to number 9. Number 9 is going to be silver nitrate. So silver is what symbol? Ag. And we know that nitrate is nitrogen plus oxygen, and nitrate is supposed to be a 3 oxygen. It's usually a 3 or a 4 if it's sulfate or some kind of 8. But in this case, nitrate is 3, okay, plus sodium, which we know is Na, and chlorine, chloride, so it's just chlorine, so it's Cl. All right, now, after the reaction, we mix them together. We'll see what's going to happen after that. Okay, so let me pause a second. I'll be right back. All right, so we have 2 solutions. This is salt water, which is clear, and this is silver nitrate, which is also clear. But if I pour the salt water in here, let me see what happens. Whoa, Okay, so we had two clear liquids. Now we have white milky stuff.